Have you ever tapped a button on an app and it just works, like perfectly?
Seamless.
Or maybe you've scrolled through a website completely lost, wondering, what was I even trying to do here?
Oh, yeah. We've all been there. Frustrating, isn't it?
Totally. Well, what if I told you that behind every single seamless interaction, every intuitive menu, and yet even every one of those frustrating error messages, there's a whole world of intentional, often unseen design?
That's right. The digital world doesn't run on magic. It really runs on systems. And learning how to design them well, that starts right here with understanding the human side of things.
Welcome back to the Deep Dive, where we take your essential sources and, really extract the knowledge you need to be truly well-informed. Today, we're diving deep into a really critical aspect of system development. We're drawing insights from Chapter 11 of Modern Systems Analysis and Design by Valacich and George.
Great chapter. It's called Designing Interfaces and Dialogues.
Exactly. And this deep dive is tailor-made for you. Whether you're a dedicated learner in BCIS 3389 looking to apply these concepts directly, or maybe you're just curious about the unseen architecture that kind of makes our digital lives possible.
It affects everyone.
We're going to unravel the systematic process of designing software systems with a special focus on how that user experience really begins to take shape in the early stages of the system development lifecycle, the SDLC.
Right at the beginning where it matters most.
Think of this as your guide to understanding how to build digital experiences that aren't just, functional, but genuinely delightful and efficient for actual people.
Yeah, making tech work for people.
So before we unpack this treasure trove of insights, just a quick ask. If you're finding value in these deep dives, please take a second to like, subscribe, and share.
It really helps us bring these insider tips and crucial knowledge to more people looking to future-proof their careers.
Absolutely. And remember, all the extra resources we mentioned, they're waiting for you right there in the description below.
Check those out. Lots of good stuff there.
Okay, let's unpack this then. At its heart, what exactly are we talking about when we say interfaces and dialogues in this whole world of systems analysis and design? They might sound a bit technical, but honestly, these are concepts you interact with every single day.
Yeah, constantly. So the chapter lays it out pretty clearly. The interface, well, that's basically the method, the way users interact with an information system.
So the visible parts.
Exactly. The tangible stuff. The screen you look at, the buttons you click, the menus you navigate, even the keyboard you type on. It's what you directly see, touch, or maybe even hear when you use any digital product.
Got it. And dialogue. That sounds like conversation.
It kind of is. Dialogue describes the sequence of interaction between you, the user, and the system. So if the interface is the physical design, the dialogue is the conversation, that flow of steps, the back and forth that happens as you try to get something done.
Okay, so like how the system guides you responds to what you do.
Precisely. And ultimately helps you accomplish whatever task you set out to do.
The chapter uses a car analogy, right?
Yeah.
That seemed pretty helpful.
Yeah, it's a classic but good one. Think about driving a car. The steering wheel, the pedals, the dashboard with all its gauges and lights.
All the controls and displays.
Right. Those are all part of the car's interface. They're the physical things you use to control it and get information from it.
Okay.
Now, the act of actually driving, starting the engine, checking your mirrors, shifting into gear, pressing the accelerator, signaling to turn, that whole sequence of actions.
A step-by-step process.
That's the dialogue. It's the conversation between you and the car to get from point A to point B. Both the interface and the dialogue are absolutely essential for a successful and hopefully safe driving experience.
And the better the design, the smoother the ride. Makes total sense.
Exactly. And it's fascinating, really. This whole idea of making computers user-friendly isn't some new concept. The field of human-computer interaction, or HCI, actually started way back in the late 1950s.
Wow, that early.
Yeah. Initially, the focus was more on the ergonomics of a computer. Basically, how could humans and these big, clunky machines sort of live together efficiently? Physical fit, minimizing fatigue, that kind of thing.
Okay. More about the physical interaction.
Right. But as technology just exploded, the focus shifted. By the 1990s, that I in HCI started to mean less interface, just the screen or the physical bits, and more interaction. People realized it was about the dynamic step-by-step process of how we engage with systems.
The dialogue part became more central.
Exactly. And this is also when usability really became the central overarching focus. HCI originally had multiple goals, safety, utility, efficiency, but usability kind of rose to the top. Some say it almost became synonymous with the entire discipline. The study of HCI effectively became the study of usability.
Interesting. So usability now covers everything.
Pretty much.
Yeah.
It implies effectiveness, efficiency, safety, utility, all of it. And for anyone building or even just evaluating systems today, understanding this evolution really underscores why modern system concepts have to be deeply human-centered.
It's not just about function anymore.
Not at all. We've moved way beyond just making a computer do something. The priority now is how intuitive, how efficient, maybe even how delightful that interaction is for the actual person using it. It's about creating systems that truly work for people, not just systems that people have to figure out how to work at.
And for our students listening, especially those in BCIS 3389, this whole discussion, it's right at the heart of the system development lifecycle, the SDLC.
Absolutely core material.
Yeah, we're talking about that systematic analysis, design, and implementation of software systems,
Yeah.
interfaces, and dialogues. This is exactly where all that theoretical analysis you do meets practical application. It's where you take those abstract requirements you gathered from users and stakeholders.
And turn them into something tangible, something real that people will actually use.
Exactly. The first 4 stages of the SDLC, planning, analysis, design, and implementation, they're all crucial. And right there in that design stage, interface and dialogue design plays this absolutely central role.
It's not just about making things look pretty, is it?
Not at all. It's about making sure the system genuinely works for the people who need to use it day in and day out. This isn't just abstract theory. It's about building real-world solutions that are both functional and truly user-friendly. Your ability as a student to effectively design these interactions, that's going to be a key skill as you apply basic systems concepts, KO3, to create robust and user-centered solutions.
It's fundamental. And when we think about how we actually talk to our digital systems, we realize there isn't just one way, right? Systems offer various interaction methods, and each one comes with its own set of pros and cons.
Okay, so different ways to have that dialogue.
Exactly. Our source material, Chapter 11, outlines several primary approaches that designers use. They range from the very technical to the, increasingly intuitive.
All right, let's break those down.
Okay, so at one end of the spectrum, you have command language interaction. Think old school DOS prompts or the command line interfaces that lots of IT pros still use today.
Like typing specific commands,
Yes.
dir, copy, that sort of thing.
Precisely. It's incredibly powerful and precise if you're an expert and you know the exact syntax. It offers speed, efficiency.
There's always a but.
But for a novice, it's like trying to speak a brand new language without any dictionary. It has a really high memory load. You have to remember all the commands, and it's very unforgiving if you make a typo.
Right. Not very user-friendly for most people.
Not generally, no. So moving towards something simpler, we find menu interaction. This is probably the most common one you see. Users select from a list of options the system provides.
Drop-downs, pop-ups, navigation bars.
All of that. The huge advantage here is that it's usually very easy to learn. It significantly reduces the user's memory load because, hey, all the options are right there in front of you.
Makes sense. What's the downside?
The main challenge is avoiding menu chaos. If you have too many menus or menus nested too deeply, it can become really cumbersome and slow to navigate. And sometimes, for expert users, clicking through menus can feel slower than just typing a command or using a shortcut.
So good menu design is key. Consistency, clear labels.
Absolutely. Logical grouping, using shortcuts, effectively like keyboard shortcuts for menu items, that all helps mitigate the downsides.
Okay, what's next?
Then there's form interaction. You encounter this constantly, right?
Yeah.
Filling out online applications, registration forms, checkout pages.
Yeah, fields for name, address, credit card info.
Exactly. This method formats data entry fields much like traditional paper forms. That makes it highly intuitive and familiar for most people. It's generally very efficient for structured data entry and helps reduce errors because the format guides you.
Seems pretty straightforward. Any limitations?
Its main limitation is often its rigidity. It's really best suited for tasks that fit neatly into that predefined structured format. It's not great for more complex, open-ended tasks.
Got it. And then there are icons, right?
Yep, that leads us to object-based interaction. This is characterized by using symbols or icons to represent functions or objects. Think about the icons on your computer desktop or the graphical user interfaces, the GUIs, in pretty much all modern software.
Like clicking a trash can icon to delete something.
Exactly. The beauty here is that it's visually intuitive. People can often recognize and understand functions very quickly just by looking at the icon. The challenge, though, lies in making sure those icons have clear, universally understood meanings. An ambiguous icon can just lead to confusion and mistakes.
True. Sometimes you see an icon and think, what on earth does that do?
Right. So clarity is key. And finally, the method that's perhaps the most ambitious and still very much evolving is natural language interaction.
Talking to our computers, like Siri or Alexa.
Precisely. This is where the inputs and outputs are in conventional human language, spoken or typed. The big promise here is extreme intuitiveness. I mean, there's essentially no learning curve for the interaction method itself because you're just speaking or typing naturally.
Sounds ideal, but I guess it's tricky to implement.
Hugely challenging. It's incredibly difficult for systems to reliably interpret the nuances, ambiguities, and sheer variety of human language. Think about accent, slang, context. It's complex. So while the dream of a system that understands you perfectly no matter how you phrase something is really appealing, we're still quite a few design cycles away from that being the norm.
Yeah, that dream of a perfectly understanding system is really fascinating. But, okay, beyond how we sort of verbally or symbolically interact, there's also the question of how we physically interact with the system, right? Through our input devices.
Absolutely. That's the other side of the coin. Chapter 11 details common input devices, and their usability can vary dramatically depending on the specific task you're trying to do.
We're talking keyboards, mice, the usual suspects.
Yeah, the familiar ones like keyboards and mice, but also things like joysticks, trackpads, touch screens, styluses, graphics tablets, even voice input.
And the choice matters a lot for design.
Immensely. Just think about the difference between using a mouse-driven interface on a desktop versus a finger or gesture-driven interface on a tablet.
Okay, yeah.
Yeah.
Like tapping something on a tablet feels natural.
Right, for selecting big items. But now try to precisely click a tiny little icon or checkbox with your fingertip compared to using a mouse pointer. The difference in accuracy is huge.
Good point. So that affects how designers lay things out.
Absolutely. It directly impacts how a designer creates the screen layout, how large the interactive targets the buttons, the links need to be, and even what kind of feedback the system needs to provide to confirm an action.
Like smaller buttons might be fine with a mouse, but need to be bigger for touch.
Exactly. A mouse interface might allow for smaller targets, maybe more complex interactions like hovering to reveal options, whereas a touch interface demands larger, more easily tappable areas and really clear visual feedback, like a button changing color instantly to confirm a successful touch.
So, as, future business leaders or IT professionals, knowing which tool fits the job is key.
It's critical. Your ability to choose the right interaction method and the right input device for a specific user doing a specific task. That is absolutely crucial for achieving both efficiency and high user satisfaction. It's not a one-size-fits-all situation in interface design. It's really about applying those sound systems concepts, KO3 again, to match the tool to the task and, importantly, to the user.
Right. Okay, so that covers the how.
Yeah.
Let's dive into the core principles for making interfaces that actually work well. Where do we start?
Well, you absolutely have to start with usability. And when you talk usability, Jacob Nielsen's 10 usability heuristics are basically the gold standard. They're a foundational set of rules, sort of like commandments, for interface designers.
Never heard of those. Things like visibility of system status.
Exactly. And others like match between system and the real world, user control and freedom, consistency and standards. 2 we'll dive into deeper later are good error messages and prevent errors because they're so critical. But at a high level, all these heuristics really emphasize clarity, consistency, and efficiency in your design.
So they're like a checklist for good design.
In a way, yeah. They provide a great framework. And beyond Nielsen, if you look at broader research in the field, certain principles consistently emerge as the most significant. These aren't just, academic ideas. They are your practical design playbook.
Okay, what are some of the big ones?
Well, essentially, these principles boil down to a few core ideas. Users need to be able to understand what's happening, they need to feel in control of their actions, and they need to be able to recover easily when things inevitably go wrong.
Makes sense. Understand, control, recover.
Right. So let's look at a couple of key examples. One of the most highly weighted principles, according to some analyses, is recoverability.
Being able to fix mistakes.
Exactly. Because people will make mistakes. It's human nature. Recoverability works in 2 ways. First, the system can try to prevent errors before they happen, maybe flagging a potential issue before you hit submit.
Like a warning message.
Yeah. And second, it allows the user to reverse actions after they've happened. Think of the undo button, probably the most famous example of recoverability, or version history in documents. There's a great quote from Jeff Raskin, who was a pioneer in HCI.
What did he say?
He said, "A computer shall not harm your work or through inaction allow your work to come to harm." Recoverability embodies that. Think of autosave in your word processor. That's recoverability saving your bacon.
Definitely needed that a few times. Okay, what else?
Then there's familiarity, sometimes called guessability. This is all about how much a user's existing real-world experience helps them understand and use a new system. Good familiarity drastically cuts down learning time.
Like using metaphors.
Exactly. The classic example is the save icon, often still looking like a floppy disk. Many users today have never even seen a real floppy disk, but the symbol has become familiar through its use in software. It leverages existing mental models to make the system feel instantly recognizable.
Even if the original reason is long gone.
Right. And closely linked to that, maybe the most widely mentioned principle of all, is consistency.
We talked about this a bit with menus.
Yeah, it's crucial everywhere. Consistency simply means that similar situations within the system should yield similar results and behaviors. A back button should always look the same, be in the same place, and do the same thing. Button styles, menu structures, even how quickly the system responds, it should all feel consistent.
Why is that so important?
Because predictability builds user confidence and drastically reduces cognitive load. If everything keeps changing, you constantly have to stop and relearn how to interact with each new screen or feature. Consistency makes it smooth.
So users don't have to think so hard.
Precisely. And there are other important principles too, like substitutivity, letting users do the same thing in different ways, maybe with the mouse or the keyboard. Predictability, knowing what's likely to happen before you click. And synthesizability, the user being able to build a mental model of how the whole system works. Together, all these principles provide a really robust framework for designing interfaces that aren't just functional, but truly intuitive, effective, and user-friendly for the widest possible audience.
That's a fantastic list, really like a designer's roadmap. But, before we even fire up Figma or whatever design tool, the UI Fundamentals Guide reminds us we have to go full UX Sherlock first.
Right.
We have to truly understand our users.
Oh, absolutely non-negotiable. This is where that analysis stage of the SDLC directly feeds into the design stage. You're taking those abstract requirements and grounding them in real human needs and behaviors.
So how do we do that? User research.
Exactly. It all starts with user research. And that means actually talking to real humans through things like surveys, interviews, and maybe most importantly, usability testing.
Watching people use your stuff.
Yeah. Watching them interact with your prototype. The guide has a great line, watching them struggle with your prototype like it's a Rubik's Cube. That's where you see the real problems. And the golden rule during testing, always ask why.
Why did you click there? What were you expecting?
Precisely. Those why questions are your direct line into understanding their mental models, their expectations, and uncovering those hidden points of friction that you, as the designer, are probably blind to.
Okay, so you gather all this info, then what? Personas.
Exactly. You take that research and you synthesize it into personas. And these aren't just vague descriptions like millennial user. They need to be realistic representations. Give them a face, a name, specific goals they're trying to achieve, maybe some typical frustrations they encounter.
So you're designing for someone specific, not just a generic user.
Right. It makes your design decisions much more grounded and empathetic. You can constantly ask, would Sarah find this confusing? Or does this help Ben achieve his goal?
And you mentioned empathy maps too.
Yeah, those take it a step further. Empathy maps help you visualize not just what users do, but what they think, feel, and say while interacting with your product or a similar one. It really shifts your focus from just designing buttons and menus to designing for actual human behavior, emotions included.
Emotions are important.
Hugely. There's a great pro tip in the sources. Users rarely remember perfectly flawless functionality, but they always remember how a product made them feel. Was it frustrating, confusing? Or did it make them feel smart and efficient? That emotional connection is powerful. And understanding all this, the users, their goals, their context within an organization is key for applying those organizational models, KO2, and basic systems concepts, KO3 effectively. You're shaping the system around authentic human needs.
That makes so much sense. Design for feelings, not just features. Okay, so user understanding is paramount. And you mentioned consistency earlier. Seems like that's a recurring theme.
It is, because it's absolutely vital. Our sources really hammer this home. The UI Fundamentals Guide puts it perfectly. Consistency is comfort. Think about it. It makes a product predictable, reliable, professional. It's like walking into a well-designed home where everything feels like it belongs, versus a house where, as the guide jokes, every room screams a different Pinterest board.
Ah, I like that. So consistency isn't just about looks.
Not at all. It provides a stable, reliable environment for users. This is a fundamental system concept, and it's also crucial for clear communication, WO1, about how the system works.
So how do designers achieve that consistency? Is there a checklist?
There's a concept called a unified design language. It has a few key components that work together. First, typography and color scheme.
Fonts and colors.
Right. You don't need 5 different fonts to prove you're creative. You need clarity. The advice is usually to stick to 1 or maybe 2 typefaces at most, and use a consistent brand color palette. Maybe 1 primary color, 1 accent color for things like buttons, and a few neutral shades. The pro tip here is avoid a color scheme that looks like a unicorn exploded. Keep it clean and professional.
Less is more, basically.
Often, yes. Second, a robust component library is essential. Think of this like your UI's recipe book or toolkit. You design standardized elements, buttons, form fields, menus, modals once, define how they look and behave, and then reuse them everywhere across your system.
So a button always looks and acts like a button.
Exactly. It ensures predictable behavior and consistent styling. It also makes life much easier for developers who can just grab the standard component instead of rebuilding it each time. Clear naming conventions for these components are also super helpful for the dev team.
Good point. And third
is leveraging familiar patterns. When you're designing something common, like navigation or a login form, stick with established UI patterns that users already understand. These patterns exist for a reason they work. Innovation is great, but the advice is to do it with clear purpose, not just for the sake of being different. Don't, for example, move your main navigation bar to the bottom of the screen just because it looks unique. That usually just introduces confusion and breaks user expectations.
Stick with what works unless you have a really good reason not to.
Pretty much. This whole unified approach to typography, colors, components, patterns is fundamental to creating sound system designs, KO3, and clearly communicating, W1, how the system operates to the user. Consistency really is comfort.
I love that phrase, consistency is comfort. It really sticks. And building right on that, there's another principle that seems closely related, simplicity. The idea that if your UI needs an instruction manual, it's probably too complicated.
That's a great rule of thumb. Simplicity in UI design isn't about making things look empty or stripping out features willy-nilly. It's about ruthlessly removing friction from the user's journey. It's about being brave enough to, as the saying goes, kill your darlings. The unnecessary elements, the confusing options, the visual clutter.
So streamlining how you present information.
Exactly. Streamlining content delivery is paramount for a good user experience and efficiency. It starts with minimalism. Every single element on your screen, every button, every line of text, every image, every decorative flourish must have a clear reason to exist. If you can't articulate why something is there and how it helps the user, our sources advise you to strongly consider ditching it.
Be ruthless.
Be ruthless. A great practical tip is to conduct a UI audit near the end of a design phase. Go through every element and ask, can I remove this without harming the user's ability to complete their task? If the answer is yes, hit delete.
Okay. What else contributes to simplicity?
Another key technique is progressive disclosure. You don't want to overwhelm users by throwing every possible option and piece of information at them all at once. That just leads to cognitive overload.
Right. Information paralysis.
Exactly. Instead, you should, as one source humorously puts it, spoon-feed it like UX porridge. Show the basics, the most common actions up front, then reveal deeper layers, more advanced options, or detail information only when the user explicitly requests it.
Like clicking an advanced settings button or expanding an accordion.
Precisely. Accordions, more info toggles, labeled modals. These are your best friends for letting users explore complexity on their own terms, keeping the initial view clean and focused.
Makes sense. Keep it simple initially. Let users dig deeper if needed.
And finally, don't underestimate the power of white space. It's not just empty space on the screen, it's elegant breathing room for your content. Good use of white space helps users focus on what's important, improves readability, guides the eye, and prevents the interface from feeling cramped and overwhelming.
So it's an active design element, not just leftover space.
Absolutely. A practical tip here is to use a consistent spacing system, often based on a grid like a 4-codon or 8-putta grid. This ensures uniform margins, padding, and spacing between elements, which makes your design feel significantly more polished, balanced, and easier to scan. The big takeaway is clear. Streamlining how you deliver content directly enhances the user experience and boosts their efficiency.
Okay, simplicity, breathing room. It sounds like it's all about guiding the user's attention.
You've hit on something fundamental there. That ties directly into how we guide the user's eye across the interface. We have to accept that our users are often skimmers. They're busy, maybe multitasking, quickly scanning the screen for the information they need or the action they want to take.
So our job is to help them find it fast.
Exactly. Our job as designers is to, as one source puts it, guide their eyeballs like a UX GPS. We achieve this through effective visual hierarchy. It's the subtle art of directing the user's attention to the most important elements first, then secondary elements and so on, without needing flashing arrows or giant text. It makes the interface feel intuitive and structured.
How do we create that hierarchy? What are the tools?
There are three primary tools designers use to build visual hierarchy. First, size and scale. This is probably the most immediate and powerful indicator of importance. Simply put, larger elements grab more attention and signal greater significance.
Like headlines being bigger than body text.
Exactly. Headlines, key buttons, important figures, they should generally be larger than supporting text, captions, or less critical controls like, say, legal disclaimers. Using consistent type scales helps create a clear rhythm and prevents what's sometimes called font soup, where everything is roughly the same size and nothing stands out.
Okay, size matters. What's second?
Second is color and contrast. Strategic use of color is incredibly powerful for drawing the eye. Think about a brightly colored call to action CTA button designed to stand out against a more neutral background.
Makes sense. Color makes things pop.
It does, but it's not just about making things pop aesthetically. Crucially, designers must ensure sufficient contrast between elements, especially text and its background, to meet accessibility standards. If the contrast isn't strong enough, users with low vision or certain types of color vision deficiency simply won't be able to perceive the information clearly. Tools like the WebAM Contrast Checker are indispensable for ensuring compliance here.
Right, so contrast for readability, not just for looks.
Yeah.
A third.
Third is alignment and proximity. Good design isn't just about the individual elements you place on the screen, it's about how you arrange and group them. Elements that are aligned together, say along a common vertical or horizontal line, and placed close to each other are naturally perceived by the human eye as being related.
Grouping related things together visually.
Precisely. Our goal is to create clear visual chunks, clusters, and pathways that intuitively guide the user through the information. Using grids and consistent spacing systems is key here. It helps maintain cleanliness, balance, visual structure, and makes the layout easy to scan, ensuring it doesn't feel like a chaotic jumble of disconnected elements. Together, size, color contrast, and alignment proximity create that essential visual hierarchy, allowing users to quickly understand what's important and navigate the system efficiently.
That's really insightful. Guiding the eye is so fundamental. Okay, now let's talk about something incredibly important that you touched on earlier. Feedback. You tap a button on your phone and nothing happens. Crickets.
The worst, the UX equivalent of getting ghosted, as you said.
Exactly. It's so frustrating. Feedback is how the system closes that communication loop, right? How it tells you, yep, got it, I heard you, and here's what's happening now. Chapter 11 actually identifies 3 critical types of feedback.
That's right, and they're all essential for a good user experience. You really need all 3 working together.
Okay, what's the first type?
First, there's status information. This is all about keeping the user informed about what the system is currently doing, especially during processes that take time. Think of messages like saving your changes, or processing your order, or maybe a progress bar showing how much of a file has uploaded.
So it reduces uncertainty, tells you it's working.
Exactly. It reduces anxiety by confirming that your action was received and something is happening. Without it, users might click again or think the system crashed.
Makes sense. What's the second type?
Second, we have prompting cues. These are designed to subtly guide the user on what they need to do next or what input is expected.
Like placeholder text in a form field.
Perfect example. Placeholder text like enter your name here, or maybe a blinking cursor showing you exactly where to start typing. They gently nudge the user forward in the dialogue, making the interaction smoother.
Okay. Status info tells you what's happening. Prompting cues tell you what to do next. What's the third?
And finally, we have error and warning messages. These are absolutely crucial for communicating when something has gone wrong. But importantly, good error messages don't just say error. They ideally explain the problem and suggest how the user can fix it.
Right. We're going to dive deeper into these because honestly, Bad error messages are probably one of the most common frustrations online.
Oh, absolutely. They can be the difference between a user gracefully recovering from a mistake or just giving up and abandoning the task entirely.
Let's get into that then.
Yeah, it's critical. Because, as we mentioned, poorly designed error messages don't just frustrate users, they have a direct, measurable economic impact, KO1. Think about shopping cart abandonment because of confusing checkout errors or failed registrations because password requirements weren't clear. The cost of bad error design can be significant.
So how do we design good error messages, ones that
Yeah.
are actually helpful? The Smashing Magazine article had a ton of detail on this.
It did. It's incredibly thorough. Let's try to distill some of the core actionable insights from it in Chapter 11. First, it's important to understand the type of error. Slips versus mistakes. They're not the same.
Slips versus mistakes, what's the difference?
Slips are usually unconscious errors. You know how to do the task correctly, but you mess up due to inattention, like a typo when you're typing quickly, or accidentally clicking the wrong button.
Okay. Autopilot errors, how do you prevent those?
You can help prevent slips with things like helpful constraints, maybe limiting the number of characters in a field, offering recovery suggestions like autocomplete, or providing reasonable defaults. Mistakes, on the other hand, are conscious errors. They happen when the user's mental model of how the system works doesn't match reality. They think they're doing the right thing, but they've misunderstood something, maybe a complex password requirement or what a particular setting does.
Okay, so how do you prevent those?
Preventing mistakes involves different strategies. Things like confirming potentially destructive actions, are we sure you want to delete this? Setting clear expectations up front, displaying password rules before the user types, allowing users to easily undo actions or change their minds, and always providing a clear way out if they get stuck. Measuring success here, KO1, involves tracking things like the average number of mistakes, error recovery time, and task completion rates. Good error design improves these KPIs.
Got it. Slips are accidents, mistakes are misunderstandings. What about how errors are shown visually?
Huge topic. Second key insight, visual clarity and non-disruptive placement. First rule, never rely on red color alone to indicate an error.
Why not? Red usually means error.
Because a significant portion of the population has some form of color vision deficiency, like red-green color blindness. Relying only on red means they might completely miss the error message. You always need to complement red text with something else, typically an icon, like an exclamation mark or an X, and maybe highlight the entire problematic section, perhaps with a thick red border or vertical line. Place icons on the left edge usually for better visibility.
Makes sense. Use multiple cues. What about lots of errors on one page?
That's where error summaries come in. Especially for long forms, if there are multiple errors, provide a summary list at the top of the page, or maybe just above the submit button where the user's attention was focused. Critically, don't place the summary below the submit button, especially on mobile users often won't scroll back down to see it after a failed submission attempt. Include links in the summary that jump the user directly to the specific error field.
Okay, summary above the button with links. Good tip. Anything else on placement?
Yes. Avoid sudden auto-scrolling or auto-jumps when errors occur. It's incredibly disorienting for users when the page suddenly shifts focus without their control. If you have a good error summary with links at the top, users can navigate themselves. Only consider adding auto-scrolling if user testing proves it's absolutely necessary. Also, and this is crucial, never cover the user's input with the error message. Users absolutely need to see both the error message explaining the problem and the input field containing their incorrect entry at the same time to fix it. Avoid tooltips that pop up and obscure the field. Instead, use inline messages, maybe in an accordion that expands below the field, pushing content down rather than covering it.
So error above the field is generally better.
For forms, yes. Displaying error messages above their corresponding input fields, while it might cause some minor layout shifts, significantly improves accessibility. It prevents issues with screen magnifiers, avoids conflicts with virtual keyboards appearing on mobile, and doesn't get hidden by browser autofill suggestions. It's generally the most robust approach.
Okay, that's a lot on visual presentation.
Right.
What about the actual words used?
Right. Third key insight. Empowering users in clear language. This ties directly into effective communication, WO1. First, consider allowing users to override an error message in certain situations.
Override an error. When would you do that?
Think about address validation or maybe phone number validation. Sometimes the validator might be overly strict and reject a perfectly valid but slightly unusual entry. Forcing the user to match the validator's rigid format might cause them to abandon the process entirely. In these cases, offering an "I confirm this is correct" override option can be a good business decision. You weigh the risk of slightly incorrect data against the cost of losing a customer. Though this isn't suitable for things with strict formats like credit card numbers.
Interesting trade-off. Okay,
Yeah.
what else on language?
Establish stop words and guidelines for error message tone. Avoid generic, cryptic messages like error code 500 or form post error. Banish technical jargon. Avoid overly informal language like oops or oops. Don't use please. It implies the user has a choice when they don't. Avoid sorry. It sounds insincere and doesn't help them fix the problem. Also, avoid judgmental words like invalid.
So what should they say?
Error messages should be concise, specific, written in plain language, clearly explain what the problem is, and most importantly, suggest an actionable solution or explain how to fix it. They should match your brand's overall voice and tone, helpful, clear, and respectful.
And provide examples.
Yes, always provide clear examples of the correct input format. Even for seemingly simple fields like dates or phone numbers, explicitly showing users what a correct entry looks like, e.g. enter date as MMD DYYYY, can significantly reduce confusion and abandonment rates. It removes guesswork.
Wow, there's so much more to error messages than just saying wrong. This focus on crafting helpful errors really seems like one of the best investments you can make in usability.
Absolutely. It directly impacts conversion rates, user satisfaction, and reduces support costs. It's a huge leverage point.
Okay, so great error messages help when things go wrong. But even with the best design, sometimes users just need a little extra guidance. That's where designing usable help systems comes in, right?
Exactly. Even the most intuitive system might have complex features or cater to users with varying levels of expertise. A good help system acts as a safety net and an educational resource. Chapter 11 provides some solid general guidelines.
What are the main principles for good help?
The core guidelines really revolve around simplicity, organization, and demonstrating solutions. Help content should be easy to understand, using clear language and avoiding jargon. It needs to be well organized, perhaps searchable or browsable by topic, so users can find what they need quickly. And wherever possible, help should show the user how to perform a task, maybe with screenshots, short videos, or step-by-step instructions, rather than just describing it abstractly.
And context matters, right? Getting help for the specific thing you're stuck on.
Absolutely. A key pro tip is that context-sensitive help is essential for usability. This means the help information should be easily accessible from the specific point in the interface where the user is having trouble. Ideally, clicking a help icon next to a confusing feature should bring up information specifically about that feature, focused directly on the user's current task. WCAG 2.1 actually has a success criterion, 3.3.5 context-sensitive help, related to this.
So help shouldn't just be a giant separate manual you have to search through.
Preferably not, no. While a comprehensive searchable help section might also be necessary, providing context-specific help right where it's needed is far more effective. Now, our sources do acknowledge that for very simple systems, or maybe single-user applications with a very limited scope, a full-blown help system might sometimes be omitted. But generally, for anything of moderate complexity or systems intended for multiple users, well-integrated and genuinely usable help is a non-negotiable part of the overall system concept, KO3. It's really about empowering users to help themselves when they hit a snag, which prevents frustration, reduces reliance on support desks, and increases their overall self-sufficiency and confidence in using the system.
Empowering users, that seems like a good goal. Okay, so we've talked about individual interface elements, feedback, errors, help. Now let's zoom out a bit. How do we design the overall flow of interaction, the dialogue itself?
Great question. Building on everything we've discussed, once you have a good handle on the individual components, you need to orchestrate the sequence of interaction, that dialogue we defined earlier. Chapter 11 outlines 3 crucial and, importantly, iterative steps in dialogue design. It's all about mapping out the user's journey through the system to achieve their goals.
Okay, 3 steps. What's step 1?
The first and arguably most critical step is to design the dialogue sequence. This is where you really map out the entire flow. You think about the user's goals, the specific tasks they need to accomplish, and you chart out the logical step-by-step path they'll take through the system's screens or functions.
So, like, if they want to buy something, what screens do they see? In what order?
Exactly. From finding the product to adding it to the cart to entering shipping info, payment info, confirming the order. You map out that entire sequence. This stage is vital because it's where you translate those initial user requirements gathered during analysis into a concrete interaction plan. It captures how the system will actually support the user's workflow.
Okay, so you've mapped out the sequence on paper or maybe in a flow chart. What's next?
Step 2 is to build a prototype. This is where those abstract dialogue sequences start to become tangible. You create working models, mock-ups, or interactive wireframes to visualize and test the proposed flow. It doesn't have to be pixel perfect at this stage. The goal is to simulate the interaction.
So users can actually click through it.
Ideally, yes. Even simple click-through prototypes are incredibly valuable. And this isn't a one-and-done thing. Prototyping is inherently an iterative process. You build an early version, get feedback, refine it, build another version, and so on.
Which leads perfectly into step 3, I imagine.
Exactly. Step 3 is assess usability. With your prototype in hand, you put it in front of actual users. You observe them trying to complete tasks using the prototype, identify where they struggle, where they get confused, where the flow breaks down or feels awkward.
Back to that usability testing we talked about.
Precisely. Based on the feedback and observations from usability testing, you then go back and refine the dialogue sequence and the prototype. This whole cycle, designing the sequence, building a prototype, assessing usability, is intensely user-focused and iterative. You keep cycling through it until the design is accepted, effectively meets user needs, and feels intuitive and efficient.
That makes sense. Design, build, test, repeat. Now, to make that dialogue sequence more concrete, especially for documentation or communication, designers sometimes use formal methods, right? Like dialogue diagramming.
Yes, exactly. For more formal design documentation or to clearly communicate the interaction flow, methods like dialogue diagramming can be very useful. Think of it as a more structured blueprint for that user-system conversation, like the example shown in Figure 1119 in the textbook, the Customer Information System.
So what does a dialogue diagram look like?
It typically uses simple box and line diagrams. Each box in the diagram represents a unique display, a screen, a form, a specific state within the interface.
Okay, one box per screen.
Pretty much. And each box usually has 3 distinct sections inside it. The top section contains a unique reference number or ID for that specific display, just for tracking. The middle section provides the name or a brief description of what that display is like, customer login screen or order summary page.
Got it. Top is ID, middle is name. What's the bottom?
The bottom section lists references, usually the unique IDs of other displays that are directly reachable from the current one. So lines connect the boxes, showing the possible navigation paths or transitions between screens based on user actions or system responses.
So it maps out the navigation flow visually.
Exactly. It provides a clear, structured way to represent the human-computer dialogue. And understanding this kind of structured interaction flow is really foundational as you, the student, move towards creating and utilizing more complex standard diagrams like use case diagrams, SO1, activity diagrams, SO2, and even class diagrams, SO3, later in your studies, KO4. It helps you conceptualize precisely how a user interacts with the system, which is key information needed for building those other UML models.
All right, it lays the groundwork for modeling the system's behavior. Okay, so diagrams help map the flow. But within that flow, users need to actually navigate. How do we make sure navigation itself is intuitive? You don't want users feeling lost.
Absolutely not. If your users feel like they need a treasure map, or worse, Hansel and Gretel's breadcrumbs just to find what they're looking for, your navigation needs a serious redesign. Effective navigation, as the UI Fundamentals Guide nicely puts it, should feel like an invisible hand guiding the user's journey smoothly and intuitively.
An invisible hand. I like that.
Yeah.
So what makes navigation effective?
Several best practices stand out. First and foremost, clear menus and labels. This sounds basic, but it's foundational. Use plain, direct, unambiguous language for all your menu items, buttons, and links. Avoid vague corporate jargon like solutions or overly cute terms like stuff. A good test is, if you find yourself needing to explain what a label means during onboarding or in a help file, it's probably the wrong label. Users should know or be able to easily guess exactly what will happen when they click something.
Predictability again. Okay, clear labels. What else?
Breadcrumbs. Both Chapter 11, calling them cookie crumbs, and the UI Fundamentals Guide emphasize their importance. These are the little navigation trails, usually near the top of a page, that show users exactly where they are within the site's hierarchy. For example, Home Products category, this page.
They show the path you took.
Exactly. They provide crucial location awareness, where am I, and also easy navigation back up the hierarchy. Users can quickly jump back one level or all the way to the home page. WCAG 2.1, Guideline 2.4.8 location actually recommends providing information about the user's location.
Useful for not getting lost.
Good.
Definitely.
Third, robust search functionality is absolutely essential, especially for any site or application with a significant amount of content. Many users prefer to search rather than browse menus, especially if they know exactly what they're looking for. A prominent, well-implemented search bar can be their fastest route to their goal.
Can't live without search on big sites.
For sure. And finally, for organizing large amounts of content without overwhelming users, designers often turn to things like mega menus and navigation drawers. Mega menus are those large drop-down panels that can display multiple levels of navigation options, often grouped logically with icons. Navigation drawers are common on mobile, sliding out from the side to reveal menu options.
Keeping menus tidy, especially on mobile.
Right. The key with these is still logical grouping, using icons effectively for quick scanning, maybe some descriptive text, and always testing them thoroughly on different screen sizes, especially mobile, early in the design process. All these practices are really about applying solid systems concepts, KO3, to create truly intuitive navigation structures that enhance rather than hinder the user experience.
Those navigation principles are definitely vital for a smooth user journey. But, sometimes the best way to learn what to do is by looking at what not to do. Let's talk common mistakes. Where do websites often go wrong with interfaces and dialogues?
That's a great point. Learning from common mistakes is crucial. Both Chapter 11 in Table 11 to 15 and general UX best practices highlight a number of frequent pitfalls that can quickly frustrate users and ruin their experience.
Okay, hit me. What are some cardinal sins?
All right, here are some big ones. Opening new browser windows unexpectedly. Users hate this. It breaks their mental model of browsing, makes the back button useless for returning, and just generally disorients them. Unless there's a very compelling reason, keep navigation within the same browser tab. Breaking or significantly slowing down the browser's back button. The back button is one of the most used controls in a browser. If your site messes with its expected behavior, like trapping the user or making it navigate incorrectly, users will get annoyed fast. Having overly complex or unreadable URLs. While maybe not a direct interface element, URLs are part of the experience. They should ideally be human-readable and reflect the site structure. Long strings of gibberish don't help anyone. Creating orphan pages. These are pages you can land on, maybe from search or an external link, that have no clear navigation back to the main site content or the homepage. They're dead ends. Every page needs a clear path, forward or back.
Yeah, landing on a page with no menu is the worst.
Totally. Others include scrolling navigation pages. If your main navigation menu itself requires scrolling to see all the options, it's probably too long or poorly organized. General lack of navigation support. This could be things like not having a clearly identifiable home link, having inconsistent menus that change from page to page, or hiding navigation in unexpected places. Hidden links. Links should look like links. If users have to guess what's clickable, that's bad design. Use standard conventions like underlining or color, and make sure interactive elements have clear visual cues on hover or focus. Links that don't provide enough information about where they lead. Link text like "click here" is unhelpful. The link text itself should clearly indicate the destination, and one we talked about earlier. Buttons or links that provide no click feedback. Users need immediate confirmation that their action was registered. A visual change, even subtle, is essential.
Wow, that's quite a list of don'ts. It seems like a lot of these directly violate those core usability principles we discussed earlier.
They absolutely do. Many of these directly violate Nielsen's heuristics like visibility of system status, user control and freedom, consistency and standards, and WCAG guidelines related to navigation, predictability, and focus visibility. Avoiding these common errors is a huge step towards improving usability and reducing the chances that users will just give up and leave.
Makes total sense. Avoid the pitfalls. Okay, this feels like a perfect moment to transition to something absolutely fundamental in modern design, something that underlies almost everything we've discussed. Accessibility.
Yes, this is non-negotiable. Designing for everyone isn't just a nice-to-have feature or an optional extra. It's absolutely fundamental to good design. The reality is, if your UI only works well for some people, it doesn't really work well at all.
So inclusive design is just better design.
It's smarter design, it's more ethical design, and increasingly, in many parts of the world, it's legally required design. The benchmark standard here is the Web Content Accessibility Guidelines, or WCAG, currently version 2.1, developed by the World Wide Web Consortium, W3C.
WCAG 2.1. What do those guidelines cover?
They define how to make web content more accessible to people with a wide range of disabilities, including visual, auditory, physical, speech, cognitive, language, learning, and neurological disabilities. But here's the key thing. Designing according to WCAG doesn't just benefit users with disabilities, it very often improves the usability and experience for all users. Think clearer contrast, logical navigation, understandable language. Those benefit everyone.
Okay, so what are the core ideas behind WCAG?
WCAG 2.1 is built on 4 high-level principles. They're often remembered by the acronym POUR. 1. Perceivable. Information and user interface components must be presented to users in ways they can perceive. This means things like providing text alternatives for images, alt text, captions for videos, and ensuring content can be zoomed or presented in different ways without losing its meaning. Users need to be able to get the information through their available senses.
Makes sense. Perceivable. What's it come?
2. Operable. User interface components and navigation must be operable. This means users must be able to actually interact with all controls and navigate the content. Key aspects here include ensuring everything works with a keyboard alone, not just a mouse, giving users enough time to read and use content, and avoiding content that could cause seizures, like flashing lights.
Okay. Perceivable, operable. You
Oh, yeah.
agree?
Understandable. Information and the operation of the user interface must be understandable. This goes beyond just being able to perceive the content. Users need to comprehend it. This involves making text readable and clear, ensuring the website or application behaves in predictable ways, and helping users avoid and correct mistakes, which ties back to our error message discussion.
Yes.
4. Robust. Content must be robust enough that it can be interpreted reliably by a wide variety of user agents, including current and future assistive technologies, like screen readers, screen magnifiers, voice recognition software. This essentially means using standard coding practices so that technology can make sense of your content.
POUR. Perceivable, operable, understandable, robust. That's a great framework.
It is. And WCAG has different conformance levels, A, the minimum, AA, the most common target, and AAA, the strictest. Conforming to WCAG 2.1 also automatically means you conform to the older 2.0 standard. Ensuring your systems meet these guidelines is a critical systems concept, KO3, for ethical design and achieving broad user adoption.
That POUR framework is powerful.
Yeah.
But practically speaking, what does implementing accessibility look like day to day for a designer or developer? What are some concrete actions based on WCAG and the UI Fundamentals Guide?
Great question. Let's break down some key practical applications. First up, color, contrast, and text size.
We touched on contrast earlier.
We did, but it bears repeating because it's so fundamental. Aesthetics are important, sure, but they always come second to readability. Designers must use strong contrast between text and its background. WCAG 2.1 has specific minimum contrast ratios, success criterion 1.4.3, generally 4.5 to 1 for normal text and 3 to 1 for large text. There are easy-to-use online tools like the WebIM Contrast Checker to verify your color choices. Use readable fonts and ensure users can resize text without breaking the layout. If someone has to squint or highlight text just to read it, you failed.
Okay, contrast and readable text are non-negotiable. What's next?
Keyboard navigation. This is another absolute baseline. If a user cannot navigate and operate every single interactive element on your page using only the keyboard, typically the tab key, Shift plus Tab, Enter, and Spacebar, then your site is not accessible, period.
How do you test that?
Simple. Unplug your mouse. Try to navigate through your entire site or application using only the keyboard. Can you reach every button, link, form field? Is the focus indicator, the outline showing which element is active, always clearly visible? Does the tab order follow a logical sequence down the page? If you get stuck anywhere, you have a keyboard accessibility problem. WCAG Guideline 2.1.
Good practical test. Unplug the mouse. Okay, what else? Images and icons.
Yes. Alt text and ARA labels. Visual elements like images, icons, and charts are meaningless to someone using a screen reader unless you provide a text alternative. Every informative image needs descriptive alt text that conveys its meaning or function. For purely decorative images, you use an empty alt attribute. All so screen readers skip them.
So don't just say alt image.
Definitely not. Be descriptive. If it's a picture of a cat, say alt, a tabby cat sleeping on a windowsill. If it's an icon button that looks like a magnifying glass, the alt text, or an ARIA label, should be search, not magnifying glass icon. ARIA labels, accessible rich internet applications, are used to provide accessible names for interactive elements like buttons or custom controls when the visible text label isn't sufficient or present. WCAG Success Criterion 1.1.1.14.1.2. Think like a narrator describing the screen.
Okay, describe visuals with text. Makes sense. What about newer interfaces? Voice.
Good point. Voice user interface, VUI design, is increasingly important with smart speakers and voice assistants. Accessibility here means offering clear, understandable voice commands, designing logical conversation flows, minimizing ambiguity, and keeping commands relatively simple and action-oriented, like play the next track rather than something complex.
Got it. Anything else major?
A couple more from WCAG 2.1 worth highlighting. Input purpose, success criterion 1.3.5. For form fields collecting common user information, name, address, email, phone number, credit card details, you should programmatically identify the purpose of each field using standardized autocomplete attributes. This helps browsers and assistive technologies automatically fill in forms correctly, which is a huge usability win for everyone, especially those who find typing difficult.
Making autofill work better.
Yeah.
Smart.
And pointer gestures, success criterion 2.5.1. If your interface relies on complex gestures like swiping with multiple fingers or drawing a specific path on the screen, you must also provide a way to achieve the same functionality using a simple single pointer action like a tap or a click. Not everyone can perform complex gestures accurately. There are also guidelines around timeouts, warning users before data loss, and ensuring status messages like item added to cart or error notifications are announced by assistive technologies. Success criterion 4.1.3. This whole commitment to accessibility is truly a critical systems concept, KO3, for ethical design and ensuring your product reaches the widest possible audience, and communicating these requirements effectively is a key writing outcome, WO1.
Wow, that's a really comprehensive overview of accessibility in practice. It's clear it needs to be baked in from the start, not bolted on at the end. Okay, so we understand the principles, the methods, the importance of feedback and accessibility. How do designers actually build these interfaces? What tools do they use?
Right. Back to the idea that it's not magic. It involves skill and the right tools. Chapter 11 mentions computer-aided analysis and design tools, and more current guides, like the one from XDF, give us a great snapshot of the modern designer's toolkit in 2025.
So why are these tools so important?
Well, fundamentally, they are the bridge between abstract ideas and concrete designs. They allow designers to sketch out initial concepts, create detailed wireframes, build interactive prototypes, and even facilitate usability testing. But, and this is crucial, the sources emphasize that the most essential tool any designer possesses is a strong grasp of fundamental design principles. Color theory, typography, visual hierarchy, interaction design patterns, user psychology, and everything we've been discussing. The software is just a means to an end.
The tool doesn't make the craftsman.
Exactly. A great designer can create effective interfaces even with basic tools, while someone without foundational knowledge will struggle even with the most advanced software. That said, the tools have evolved dramatically from basic graphic design software to incredibly sophisticated platforms specifically built for interface and interaction design.
Okay, so what are the main types of tools designers use today?
They generally fall into a few key categories, often used at different stages of the design process. First, you have wireframing tools. These are used early on to create low-fidelity blueprints or skeletal layouts. They focus purely on structure, content arrangement, and intended functionalities, deliberately ignoring visual details like colors and specific fonts.
Like architectural blueprints for a website.
Precisely. Tools like Balsamic are famous for this. They often produce wireframes that look intentionally sketchy or hand-drawn. This is actually a feature, not a bug. It helps stakeholders focus on the core structure and flow without getting hung up on visual aesthetics early on. It clarifies scope and gets crucial feedback when changes are still cheap to make. Other tools like Sketch, though more high fidelity, can also be used for wireframing.
Okay, wireframes for structure, then what?
Once the basic structure is agreed upon, designers move to prototyping tools. These allow you to create much more realistic, interactive mock-ups that demonstrate how the final product will actually look and behave. You can link screens together, define button interactions, add animations, and simulate the entire user flow.
So people can really experience the design.
Exactly. Figma is currently a hugely popular choice here. It's cloud-based, making collaboration super easy, has powerful vector drawing tools, supports real-time co-editing, manages design assets, and allows you to build sophisticated interactive prototypes all within the same application. Axure RP is another powerful option, known for handling very complex interactions and detailed specifications. These tools let you test the dialogue part of the design much more effectively.
Figma seems to be everywhere right now. Okay, wireframing, prototyping. What about research?
Good catch. There are also specialized user research tools. These help designers gather that critical user feedback we talked about earlier. This category includes tools for creating and distributing online surveys, SurveyMonkey, Google Forms, platforms for conducting remote user interviews and recording sessions, look-back user testing, tools for visualizing user behavior like heat maps and session recordings, Hotjar, and platforms for specific research methods like card sorting or tree testing to evaluate information architecture, Optimal Workshop.
A whole ecosystem of tools. Any tips for using them effectively?
Yes, a few best practices emerge. Utilize templates and UI kits whenever possible. Don't reinvent the wheel for common elements. Use grids and layout features within the tools to maintain consistency and alignment. Master keyboard shortcuts for your chosen tool. It dramatically speeds up workflow. For larger projects or teams, sync your designs with a shared design system to ensure everyone uses the same components and styles. Crucially, actively use the accessibility features built into many modern tools, checking color contrast, ensuring logical layer order for screen readers, etc. Prototype early and often, iterating based on feedback.
So it's about choosing the right tool for the specific job at hand, right? A drill, not a hammer, as you said. This really connects to applying project management methodologies, KO5, and demonstrating those practical skills, SOs, in system implementation and evaluation.
Precisely. The tool supports the process, but understanding the underlying principles and the project goals is paramount.
Choosing the right tool for the job, a drill, not a hammer.
Mm.
I love that analogy. And okay, after you've used these tools to build your amazing prototype, you can't just ship it, right? You mentioned testing. Designing a UI without testing seems risky.
Extremely risky. It's exactly like that cooking analogy you used, cooking without tasting. You could wing it, but you'll probably oversalt the whole thing, or worse. UI design isn't a one-shot deal. It's a living, breathing process that absolutely thrives on feedback, testing, and continuous improvement. This is where those project management methodologies, KO5, about iteration and validation, really come into play in a practical way.
So what are the main ways designers test their work? Usability testing seems key.
Usability testing is your absolute best friend, as we've touched on. There is simply no substitute for watching real people, representative of your target audience, actually try to use your design to accomplish specific tasks. This is where you uncover those hidden friction points, the confusing labels, the moments where users get completely stuck, things you, the designer, are often too close to see.
How many users do you need for that?
You'd be surprised. Research consistently shows that you can uncover the vast majority, often around 80% of major usability issues, by testing with just 5 users. The key is to keep the tests relatively small, but conduct them frequently throughout the design process, rather than one big test at the very end when changes are expensive.
5 users find 80%. That's efficient. Okay. What else besides watching people use it?
Another powerful technique, especially for optimizing specific elements, is A/B testing, sometimes called split testing. Let's say you're not sure which version of a button label, sign up now versus get started free, will perform better, or if one page layout converts more users than another.
Don't argue about it. Test it.
Exactly.
Yeah.
With A/B testing, you show different versions to different segments of your users simultaneously and let the data decide which one achieves your goal. Example, more clicks, higher sign-up rate, more effectively. The crucial thing here is to test only one variable at a time so you know exactly what caused the difference in performance.
It makes sense. Isolate the variable. What about website data?
Absolutely. Analytics tools, with Google Analytics being the most common, provide a goldmine of quantitative data about how users are actually behaving on your live site or app. Numbers don't lie. Analytics can show you where users are dropping off in a conversion funnel, which features they use most or ignore completely, how long they spend on certain pages, and much more. Setting up custom events and tracking specific user flows, funnels, gives you targeted insights to drive design improvement.
So analytics tells you what is happening.
Right. And then tools like heat maps and click tracking can help you understand why. Heat maps visually show you where users are clicking, tapping, or even just moving their mouse cursor most often on a page, the hot zones. They can also reveal ghost towns, areas you thought were important, but users are completely ignoring. Click tracking can even show you if users are repeatedly clicking on elements that aren't actually clickable, which is a clear sign of design flaw or unmet expectation.
Seeing where people click or try to click, that's powerful.
It really is. All these testing methods feed back into that iterative design process. You prototype early, you test often, you analyze the results, and you refine your design based on that evidence. You have to be prepared to course correct or fine-tune things to maximum effect, as one source puts it, before you invest significant development resources. These testing and iteration methods are absolutely central to applying project management methodologies, KO5, effectively, and demonstrating those practical skills, SOs, in system implementation and evaluation.
It really underscores that design is a process, not just a deliverable. Okay, so testing is crucial, but designers don't work in isolation, do they? How does collaboration fit into all this?
You've hit on another absolutely critical component, host. Great UI, great systems, they simply don't happen in a vacuum. It's fundamentally a team sport. Effective design requires tight feedback loops and constant communication between designers, developers, product managers, researchers, writers, and other stakeholders. This is a critical organizational model, KO2, that ensures the final product is well-rounded and technically feasible.
So how does that collaboration work best in practice?
Several key aspects contribute to successful collaboration. First is the design handoff process, when the designer passes their work over to the development team to be built. You want this to be as smooth and unambiguous as possible.
Avoid throwing designs over the wall.
Exactly. Designers should provide clean, well-organized, and thoroughly annotated design files. Tools like Figma and Zeppelin are great for this. The handoff should include not just the final screens, but also detailed specifications or red lines showing spacing, sizes, colors, font styles, asset exports, and maybe even specifications for animations or interaction states, like hover effects. The goal is to minimize guesswork and reduce back-and-forth questions from the developers. Clear communication, WO1, is paramount here.
Makes sense. Clear specs save time. What else?
Regular check-ins are essential. Design work shouldn't happen in a silo and then be revealed in a big bang. Stay connected with the entire team developers, PMs, maybe even marketing or support through regular meetings like daily stand-ups, asynchronous updates in shared channels like Slack, or maintaining shared project documentation. Frequent, informal check-ins catch potential issues or misunderstandings early, keeping everyone aligned and preventing surprises later in the development cycle.
Keep the conversation going.
Absolutely. And related to that is actively cultivating a strong feedback loop. The best designers aren't necessarily the ones with all the perfect ideas up front. They're often the ones who are best at soliciting, receiving, and integrating feedback. Actively ask developers, is this feasible? Ask product managers, does this meet the business goal? And critically, listen to user feedback from testing.
Be open to critique.
You have to be. Embrace feedback, even if it's critical. Learn to separate yourself from your design critique is about making the work better, not about your personal worth. Every round of input, thoughtfully considered, usually sharpens the final UI.
Good advice for any creative field, really.
Definitely. And one final collaborative technique worth mentioning is using co-design workshops. If you really want buy-in from stakeholders, especially on major design directions, consider inviting them into the design process early on. Running structured workshops where stakeholders can contribute ideas, sketch solutions, or provide feedback collaboratively can get everyone aligned much faster and can even turn initial skeptics into champions for the design. This whole collaborative approach is essential for applying those organizational models, KO2 effectively, and ensuring that the complex design concepts are communicated clearly, WO1, to diverse audiences, leading to a final product that truly meets the needs of the entire organization.
Those collaborative efforts sound absolutely vital. Truly, teamwork makes the dream work, as they say.
Okay, so as we kind of look towards the horizon, UI design isn't static, is it? It's always evolving. What are some of the trends shaping future interfaces and how we interact with systems? Staying updated seems crucial. It really is. UI design is a dynamic field, and keeping an eye on emerging trends is definitely part of the job. Here are a few notable ones that are shaping interfaces right now and likely into the near future.
Okay, what's big right now? Dark mode.
Dark mode is definitely huge. It's moved beyond being just a niche preference for developers. It's now pretty much a user expectation for many apps and websites. Users appreciate it because it can reduce eye strain, especially in low light conditions. It often looks sleek and modern. And on certain screen types like OLED, it can actually save a bit of battery life.
So designers need to plan for it.
Absolutely. The key is not to treat it as an afterthought, just inverting colors. Good dark mode design requires creating a distinct, fully supported dark theme, often using semantic color tokens in the design system to ensure colors adapt appropriately and maintain accessibility, especially contrast, in both light and dark modes.
Got it. Design two themes, basically. What about visual styles? Anything trendy?
Yeah, there are always aesthetic trends cycling through. Recently, we've seen things like neumorphism and glassmorphism. Neumorphism aimed for a soft, tactile look, almost like extruded plastic, using subtle inner and outer shadows. Glassmorphism uses background blur effects to create a frosted glass look for interface elements.
They can look cool, right?
You can look very cool in design portfolios, yeah.
Oh.
But the pro tip here is to use these kinds of strong aesthetic trends sparingly and carefully. They can sometimes pose accessibility challenges, particularly with contrast, if not implemented thoughtfully. The golden rule remains: don't let form outrun function. Always prioritize usability and accessibility over chasing the latest visual fad.
Good point. Function first. What about interaction methods? Anything new there?
Well, voice and gesture control are rapidly moving from sci-fi concepts into everyday reality. Think about smart speakers, voice assistants on our phones, wearables, and even touchless interfaces using hand gestures, which gained traction during the pandemic.
Talking to our devices, waving at them.
Exactly. Designing for voice and gesture opens up new possibilities for accessibility and efficiency, especially for situations where users' hands or eyes are busy, like driving or cooking. The design challenges involve keeping voice commands natural and intuitive, minimizing ambiguity, rigorously testing with real users in real contexts, and always providing fallback interaction methods for users who prefer not to or cannot use voice or gestures.
Always have a backup plan.
Always. And looking even further ahead, 3D and augmented reality, AR, are starting to create incredibly immersive and engaging experiences, particularly in areas like e-commerce, visualizing furniture in your room, education, interactive models, and gaming.
Stepping into the digital world more literally.
Kind of, yeah. These technologies can truly wow users and provide unique value, but designers need to be mindful of the potential downsides. 3D models can be computationally heavy, impacting performance and loading times. AR implementations can be complex to develop and require users to have capable devices. The advice here is to use 3D and AR where they add genuine value to the user experience, not just as a gimmick. Prioritize speed, clarity, and purpose over novelty.
So exciting possibilities, but ground them in good UX.
Precisely. While these emerging trends are exciting and push the boundaries, they must always be integrated thoughtfully with those solid UX fundamentals, usability, accessibility, clarity, consistency to be truly effective. They illustrate how our core systems concepts, KO3, are continually adapting and evolving to incorporate new technologies and interaction paradigms.
That's a great perspective. It really brings us full circle.
It does. So, from those fundamental definitions of interfaces and dialogues through the nitty-gritty details of interaction methods, usability principles, those critical error messages, the absolute necessity of accessibility, and finally the tools and trends that bring designs to life. We've really seen that the digital world doesn't run on magic. Not at all.
Right. It runs on systems.
It runs on thoughtful, user-centric systems. This deep dive into Chapter 11 and these related concepts really reinforces how designing intuitive and effective interactions isn't just about making things look nice. It's about deep user understanding, applying systematic processes, constant testing and iteration, and maintaining an unwavering commitment to the end user experience.
Making sure every interaction works for the person using it.
Exactly. It's about making sure that every tap, every swipe, every click, every voice command is a deliberate, well-considered part of a carefully orchestrated digital conversation between the user and the system.
That's a perfect summary. And as you, our listeners, continue your journey in BCIS 3389 and whatever comes next, really remember these principles. They'll empower you to not just use the systems around you, but to actually build them, to design them in ways that truly serve people effectively and ethically.
That's the goal.
So if you enjoyed this deep dive, if you found it valuable, please do make sure to like, subscribe, and share it with others who might benefit. And definitely check out the description below for links to all the resources we talked about and more.
Lots of good reading there.
For sure. Behind every tap, swipe, and click is a system that someone designed. Until next time, keep building the future one process at a time.